Hi guys, it's Mrs. Tucker. Well, I've got some good news and some bad news for you. The good news is when y'all get to ninth grade, y'all get to use a calculator. Okay? That's the good news. So what's the bad news? Yeah, until then, your computation has to be done by hand. All right? Well, okay, in the 8th grade, there's going to be some units where we do use calculators just to speed things up. All right? So anyway, I want to take some time here to work some examples with you so that you've got good solid examples in your journal as reference. Okay? We're going to be doing computation tests all year long, a bare minimum of 3 per 9-week grading period, so there'll be at least 12 of them we do. And once you get 100% on one of them during a 9-week period, you don't have to take any others, okay? You're exempt from all other computation tests. So I'm going to chunk this into 3 separate videos, and let's just get started, okay? Number 1 on the computation test always looks like this. It might be 2 numbers, it might be 3, but you're adding large numbers. Most kids don't have any problems with this, maybe just some computation errors. When I go through and add, when I'm doing the columns, I start by looking for groups of 10. Is there any way to form 10? Because it just makes it faster for me to add that way. So when I look at this column here, I see the 7 and the 3. That makes 10. Add 6 and you get 16. Carry the 1. Okay, can we make a group of 10 out of this column here? Yeah, we can with the 1 and the 9. That makes 10. There's 5 and 2, that's 7. So 10 plus 7 is 17. Okay. Can we make a group of 10 here in this column? Yeah, we can with the 1 and the 9. That makes 10. The 7 and the 8 make 15. So 10 plus 15 is 25. And let's see, group of 10 here. Yeah, we can with the 6 and the 4. That's 10. 9 more makes 19. 2 more makes 21. Okay, so the answer is 21,576. When you guys get done, I want you to either highlight your answer, put a box around your answer, or circle your answer. I want to be able to find your answer. Okay, the second problem on our computation test always looks like this. It's always a subtraction problem where you have to do some borrowing. All right? Well, first of all, let's make an estimate. Let's call this 300,000. Let's call this 100,000. 300,000 subtract 100,000 is 200,000, but I'm going to have to subtract more than that. So I know my answer should be a little less than 200,000. All right? So I've got myself an estimate. Okay, let's see here. I'm going to have to borrow here. I can't work this, can't do this. I'm going to go all the way over here, and I'm just going to start borrowing. And I'm just going to carry it all the way down the line. I'm going to borrow from the 3 and make that a 2. That makes this a 10. I'm going to borrow here, make that a 9. That makes this a 10. Borrow 1 here. That makes this a 9. That makes that 14. Borrow here, that makes that 13. This becomes 10. Borrow here, that makes the 10 a 9. That makes this a 14. And I can't tell you how many times kids mess up right here, especially if that's a 0, and they go ahead and make it a 9 also because they see all these 9s across the top. Don't do that. Okay, now we're ready to subtract. 14 subtract 7, 9 subtract 5, 13 subtract 8. Oops, made a mistake. Oopsie, glad I caught that. I want to get 100% on this. That's 0. 9 subtract 2 is 7, and 1. Okay? Now, I see every year a number of kids that want to get 100% so they don't have to do this over again. And what can you tell me that they do to double check and make sure this answer is correct? How have you been told to double check your subtraction answer? Yeah, with addition. Let's add that number back to it and see if we don't get that for an answer. Okay, so let me erase this so I can see what my original number was right there. I am going to add back 129, 857, and see if I don't get 300,404 back. Okay? Let's see what happens here. Let's see, that's 1314. That's going to be 10. That's also going to be 10. Did I get back to my original? Yes, I did. So I know that 170,547 is my answer. There's a lot of numbers happening here. Please highlight, circle, or box your answer. Okay? Number 3. All right. Every year we see kids do something really crazy. It's a common error, and the common error we see every year is kids do this. Can you tell me what mistake was made? Okay. Take a look at this. I have 40 and I'm subtracting 8.71. Well, okay, that's really close to 9. That's like taking 40 and subtracting 9. If I take 40 and subtract 9, what answer do I get? Yeah, I get 31. And anytime I do an estimate, I put my estimate in an answer, and I usually park it somewhere. I'm going to park my estimate up here. Okay? My estimate's 31. So are you going to get 31 when you do this? Yeah, I don't know what that is. What should they have done? First of all, find the decimal point in 40. Where is your decimal point in 40? Yeah, it's right there. The next thing you're going to do when you're adding and subtracting with decimals is line your decimal points up on a line. They have to be in a line. I like to draw the line. So here's my 40, 40. You can put extra zeros out here if you want to. And we're going to subtract 8, line up your decimal point, 7, 1. And I am going to throw those extra zeros out there. Now we can subtract, okay? And it looks like we're going to wind up borrowing, right? Here we go again. Makes that a 10, make that a 9, makes a 10. Borrow 1 whole, that makes that a 9, makes this a 10. Do not do this. I don't know why kids do that. Don't do that. You're done. You're done carrying at this point. All right, 10 subtract 1. 9 subtract 7. Bring down your decimal point. 9 subtract 8. And the 3. All right? Pretty easy. Okay, the next problem, number 4 on your computation test, is always addition with decimals. Number 3 is always subtraction with decimals. Number 4 is always addition with decimals. And what do you think the common error is here? Yeah, kids don't know what to do with the decimal point. You have to do what with your decimal points? Yeah, you need to line them up. So here we go. Draw yourself a line. If you draw yourself a line, I'm going to think you're the smartest kid in the class. Second thing you need to do is go find all your decimal points. Where's the decimal point in 33? Yep, right there. Start lining them up. I want to put all of these decimals on the line. So 2.7, 0.45, and 33 point. Do you see how I wrote it real big too? That helps a ton. And let's go ahead and put in some zeros here as fillers. And now we can add. All right, here we go. 11, that makes 6 and 3, and don't forget what? Yeah, your decimal point. Circle box or highlight. Now, before we move on, is my answer reasonable? Okay, I've got 33 here. 0.45, well, that's a little under a half. I mean, if you were going to round it one way or another, you might call that 0. And 2.7 is real close to what? Yeah, that's real close to 3. And if you add those together, we get what for an answer? Is our answer reasonable? Yes, it is. Okay, moving on. Here's where things get a little more complicated. Now we're multiplying with decimals. And before we start, let's estimate, okay? 0.89, if you rounded this to the tenths place, that's 0.9. And if you rounded that a little farther, that becomes what? Yeah, you could call that 1 whole multiplied by 7.7, which gives us what for an estimate? Yeah, 7.7. But if I multiply by a number that's less than 1, should my answer be bigger than 7.7 or less than 7.7? Yeah, since 0.89 is a little smaller than 1, my answer should be a little smaller than 7.7. So, I don't know. Let's change it and make it a little bit smaller. What do you want to call it? 6.8 maybe? All right. Put it in a bubble. That's my estimate. Let me show you what the common error is on this. Common error, most kids know you don't have to line up the decimal point. If your teacher taught you to line up decimal points, that's fine. You'll still get the same answer. Take a look at this. I see a lot of this. What do you notice happening here? Okay, one of the things I notice is things are starting to slide. We're not getting numbers in the right columns. They're not being lined up properly. So then when I go to add, it's not adding right, because the mistake here is this number right here should not have been a 2. It should have been a what? An 8. This number here, we didn't even need that number there. All right. And then the next mistake I always see is incorrect number of decimal places. All right. Lots of ways to make errors here. So my suggestion, the kids that are the smartest either go get a piece of graph paper, or they turn their notebook paper sideways, some scratch paper, and use those columns to line things up. Okay, 89, I'll put my point right there. 7.7, put my point right there, because you don't have to line them up. You can if you want to. But these lines will keep everything in the right column, so when I get to the end, I can add it all up right. So let's start multiplying. Let's see, that's 62. All right, now multiply this way. I know a lot of you guys like to put a 0 right there. That's good, you should. Okay, that's 63. That's going to be 62. See how nice those columns are to have? Let's add it up. 3, 5, 8, 6. Almost done. Where do I put my decimal point? Well, let's see here. I moved over 1, 2 places here. I moved over 1 place here. That's a total of 3 decimal places. So starting at the end here, 1, 2, 3. That's where my decimal point goes. So my answer is 6.853. Box, circle, or highlight your answer. Hi guys, it's Mrs. Tucker. Okay, we're still working on computation tests, the notes for our journal. So you've got some examples to go off of. All right, number 6 on the computation test is always long division. And this is where kids mess up all the time. I guess math teachers have just been teaching this wrong. Shame on us. All right, so we're going to try to, I'll do the best I can to give you some ideas on where to go with this. All right. Number 6 says, if necessary, round to the hundredths place. So I've got 3.224 divided by 0.07. And before I start, I want to estimate what my answer is. Okay? So forget about this problem for a minute. Take a look at what I've got going here. Help me work these out. What's 24 divided by 4? Yep, the answer's 6. What's 24 divided by 3? Okay. What's 24 divided by 2? What's 24 divided by 1? What's 24 divided by 0? Yeah, that one's special. Why is that one special? You can't divide by 0. That's right. Okay, now I want you to take a look at this. The 24 always stays the same, but the number that you're dividing by keeps getting what here? Yeah, it keeps getting smaller and smaller and smaller. And as our divisor, that's called a divisor, as our divisor keeps getting smaller and smaller and smaller, what is happening with our quotients? It's getting bigger and bigger and bigger and bigger. Of course, we have to skip this one. Okay, we have to skip that one because you can't do it. What do you predict is going to happen when I take 24 and divide by 0.1? What do you think is going to happen? Take a look at these answers. Bigger, 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 bigger. We're going to have to jump over this one. What do you think happens right here? I'm thinking it probably should get bigger. Okay? So let's take 24 and divide it by 0.1. Big mistake kids make on this one is putting the wrong number in the house. I don't know why everyone seems to think the biggest number goes in the house, and that's not always true. Okay? So when I divide, before I can start, I want to make this a whole number. And basically what I'm doing is multiplying it by 10. If I wrote this as a fraction, like this, and I multiply by 1, I still get that number. Well, what if I multiply it by 10 over 10? 10 over 10 is 1. So I'm still multiplying by 1. But when I multiply by 10, that makes this number down here 1 instead of 0.1. Of course, that makes this up here 240. So that's why we do this. We scoot the decimal place over once here. My decimal place is right there, scooted over once. And I put that decimal point right up here on the line. Okay, and I made it big so I don't lose it. Put a 0 right there. Okay, how many times does 1, we've just got one whole here now, let's get rid of this. How many times does 1 divide into 240? Yeah, 240 times. So the answer here is what? Yeah, it's 240. Okay, now, if we divided by 0.05, tell me something you know to be true about the answer. Yeah, it's going to be less than 240, but bigger than 24. Okay? All right? So, give me an estimate before we do this common error. Give me an estimate to put in my bubble when I take 3.224 and divide it by 0.07. Give me some kind of estimate. I know for sure the answer has to be what compared to 3.224? It's going to be bigger. I don't know, let's call it 50. I don't really know what it's going to be. I just know it has to be bigger. So that way when I get my answer, if my answer's smaller, I know I've made a mistake. Okay, common error. Take a look at this. We see this every year. What's wrong with this? Yeah, they put the wrong number in the house. 3.224 is being divided up into pieces, okay? The number that's being divided into pieces, and I don't care if it's a big number or if it's smaller than the other number, the one that comes first always goes in the house, all right? Common error. Okay, so let's straighten that out. We're going to put 0.07 out here because 3.224 is what's being divided into pieces, okay? Now, the next thing we have to deal with is this decimal point out here. You remember in that example we multiplied by 10 over 10? Well, in this example, I'm going to multiply by 100 over 100 because when you multiply by 100, it moves your decimal point 2 places to the left, or to the right. That's why we do it. But I'm also going to have to do what here? Yeah, move that decimal point 2 places to the right. So it falls right there. And I want to see you guys do this because I see a lot of kids put the decimal point in the wrong place up here on the line and get all the numbers right, but the decimal point's in the wrong place. And you know how you would avoid doing that? is if you draw in these columns. That's what my smart kids do. They get a piece of graph paper, they turn their notebook paper sideways, or they just draw in the columns and keep everything lined up. Okay? Okay, so let's start dividing. 7 doesn't divide into 3. How many times does 7 go into 32? Yeah, it goes in there 4 times. See, I'm keeping everything nice and lined up. 7 times 4 is 28. Subtract. Okay, I'm going to have to borrow. All right. Now, smart people put in those little arrows and the lines so they know where they're at. Let's bring down the 2. 7 goes into 42 how many times? Yeah, 6 times. 6 times 7 is 42. Subtract. We get 0. I have to bring this down. Okay? Bring down the 4. How many times does 7 go into 4? Well, it doesn't. You have to put the 0 there. You have to. It's a must. 0 times 7. Subtract, and we get 4. Okay? Now, we're not done. Come back up here. It says round to the hundredths place. Do you know where the hundredths place is at? Do you remember where the hundredths place is at? Okay, forgot I had this here. All right, the hundredths place. A lot of kids forget this is a rounding problem. Not only do you have to divide, you have to know how to round. Where is the hundredths place? Well, hopefully you guys have something that looks something like this in your journal now. Here's my decimal point. The 4 is in the tenths place. The 9 is in the hundredths place. But when you're dividing like this, to decide if this 9 stays a 9 or becomes one bigger, you have to take your answer out one more decimal place. We've got to see what number's in the thousandths place to see if that's going to make the guy in the hundredths place round. Okay? So we're not done. We're only in the tenths place. What do I have to do? There's the hundredths place. There's the thousandths place. So take your place here that they want you to round to and add one more place value to it. All right? In this case, we're getting one more place value smaller. All right, here we go. Still dividing. 7 goes into 40. Let's see. Let's put it 5 times. That's 35. Subtract and you get what? One more time. I got to see what number is in that thousandths place. 7 goes into 50 how many times? Yep. 7 times 7 is 49. When you subtract, you get 1. Okay. Now, it says round to the hundredths place. I've got a 5 in the hundredths place, but I have a 7 in the thousandths place. Does this 5 stay a 5? No, the 7's going to make it round up to a 6. So our final answer is 46.06. Circle, box, or highlight. Okay, problem number 7 is always going to be long division again, but instead of having a decimal part as a remainder, we're going to leave our fraction as a remainder. Leave remainder as a fraction. Okay? Common error. What is the common error here? Yeah, they leave it as a decimal and not a fraction. If you leave it as a decimal, I'm going to mark it wrong. Okay, so all of my smart kids do what? Yeah, they line it up, keep everything in a column. And let's just start dividing. 44 does not divide into 3. 44 does not divide into 35. I'm going to have to go all the way out here. Okay, and I know some of you guys do this. If I multiply by 10, I get what? Yeah, you guys should know if you multiply by 10, you just throw a 0 out on the side here. Come on, my computer's being slow. Okay, I know that's too big. Got to go a little bit smaller. So I know some of you got, whoops, I don't know where that 9. I know some of you guys might try 44 times 9. You might try 44 times 8. You know, if you want to do that, that's fine with me. Turns out it goes in there 8 times. Okay? 8 times 4 is 32. 8 times 4 is 32, 33, 34, 35. Subtract. Bring that down. Okay? 44 goes into 62 how many times? Once. 1 times 44. Subtract. Okay, I'm going to have to borrow or carry or whatever you were taught to call it. Okay, the tendency is for kids to want to throw in a decimal point and bring down a 0. We're not going to do that. Why? Yeah, they want our remainder as a fraction. So 44 goes into 3,582. 81 whole times, and another how many 44ths of a part of a whole? Yeah, this guy right here goes over the top here, and that becomes your remainder in fraction form. But what do you have to do with this type of remainder? Yeah, you always have to reduce. If you guys don't reduce, I'm going to mark it wrong. Okay? Let's see here. They're both divisible by what? I know for sure they're both divisible by 2. Let's try that. So I get 81 and 9 over 22. Does it divide out any farther than that? No. Can't reduce it any farther. So there's our answer. 81 and 9/22. Okay, problem number 8 is always going to be addition with fractions. If you change these fractions to decimals, I am not going to count it correct. I want to see your answer as a fraction. If I look at your paper, and I always do, if I see you convert them to decimals and then try to attempt to convert them back to fractions, it's wrong, okay? I want to see you do all of your work in fraction form, and you know how to do it. When you're adding fractions and the denominators are different, what do you have to do? Yeah, you have to have a common denominator, okay? Well, let's start with the easy part. Let's add these pieces together. Let's add all of our wholes together. All right, let's do that first. Let's see. 2 plus 3 is 5, plus 1 more is 6. Okay. 3 plus 3 is 6, plus 2 more is 8. All right. Now look at this. A half. 2/3 is bigger than a half, and 7/9 is bigger than a half. So chances are when you put those all together, we're going to have something bigger. I know it's going to be bigger than 1. It might be bigger than 2. It might be a little less than 2. So my prediction is my answer should be somewhere around 87, probably a little bit bigger than 87. Okay? Let's find a common denominator. I have 2, I have 3, and I have 9. What is my common denominator? Okay, I got cut off there. Ran out of time on that one. Okay, so we've added these together here. We've added the whole numbers together. Now we need to add the fractional pieces together. I remember saying that the common denominator was 18. So let's make equivalent fractions out of these right here that all have denominators of 18. All right? So in order to turn the 2 to 18, I have to multiply by 9. So I'm going to do the same up here. 9/18 is the same as 1/2. To turn the 3 into 18, I have to multiply by 6, so I have to do that to the top also. What you do to the bottom, you better do to the top. So we get 12/18 here, and down here I have to multiply 9 by 2 to get 18. So I'm going to multiply 7 by 2 and get 14. All right? Now that our denominators are the same, I've got 9/18 here of a whole, 12/18 here of a whole, and 14/18 of a whole right there. I need to add all those fractional pieces together. Okay? So 12 plus 9 is 21, plus that extra 14, that gives you 35. So I get 35/18. So far, I know my answer is 86 and 35/18. So what do you think about that answer? Yeah, we've got an improper fraction happening here, and we don't leave our answer like that with an improper fraction in it. So we're going to have to go ahead and change this piece right here, that improper fraction, to a mixed number. So I need to know, and what this says is it says 35 divided by 18. It says this, 35 divided by 18. How many times does 18 go into 35? Well, it goes into 36 twice. So it goes in there once. That's 18 when you multiply. Let's subtract. Carry. That's going to be a 7 and a 1. So that turns out to be 1 and 7/18 for this improper fraction, which we have to add to our 86. So our final answer is 87 and 7/18. Okay? Got that one? All right, let's move on. Number 9 is always going to be a whole number subtracting a mixed number. And before I do this problem, I want to show you a simpler one, okay? Because the process is exactly the same. Okay, my computer's being slow. All right, let's say we've got this problem here. We've got 3, and we're going to subtract 1 3/4, okay? Well, if I had 3 subtract 1, the answer's 2. But I have to subtract another 3/4. And I know some of you already know the answer, but I want to show you a visual of what's happening here. So I've got my 3 wholes, and I'm subtracting 1. So let's knock off that 1 right there. But I'm also removing another 3/4. So what I need to do, since these are wholes, is I need to borrow one of the wholes and break it up into 4 equal pieces. Okay, you see what we did there? So once the whole is broken up into 4 equal pieces, then I can remove 3/4. So that 1 whole is the same as 4/4. So what I did mathematically is, of the 3, I took 1 and busted it up. When I take this 1, I've got 2 wholes remaining, but I'm going to bust it up and call it 4/4. 2 and 4/4 is just another name for 3. Okay? So now I can take the 2 and subtract 1 and get this 1 whole right here. And I can take this 4/4 right here and remove 3/4 from it. So we're going to take that one and take that one away and take that one away, and I'm left with 1/4. Okay? So let's go back to that original problem. We're going to do the same thing here. We need to borrow a whole, since we have a whole number and we're subtracting a mixed number. It's real easy to take 46 and subtract 4, you get 42. But I also need to subtract another 2/7. So I'm going to borrow a whole from the 46, and now I'm going to call it 45. It's going to be 45 plus another whole, and your whole is determined by that guy right there. 7/7. Since 7/7 is another name for 1, when you add it back to 45, you get the 46 we started off with. Okay, so that 1 whole that we borrowed, I'm going to call it what? Yeah, we're going to call that 1 whole I borrowed 7/7. Now I've got I've got a whole that's been busted up into 7 equal pieces, and I can remove 2 of them. So 45 subtract 4 is 41, and 7/7 subtract 2/7 is 5/7. All right. If I need to pause the video, you guys just let me know and I'll do that, okay? 10 is always going to be a subtraction of mixed numbers problem, and most of them are going to be way easier than this. So if you guys can do this difficult problem, you should be able to handle those easier problems I'll be throwing at you this year. Okay, let's see. First thing we need to do, if we're going to subtract, what's the first thing we need to do? Yeah, we need common denominators. Between 1/5 and 2/3, what's your common denominator? Yeah, 15. So, what'd you multiply 5 by to turn it into 15? Yep, so I got to do that up here. 1/5 is the same as 3/15. 2/3 is the same as how many 15ths? Well, what did you multiply the 3 by to turn it into 15? Yep, I got to multiply the numerator by that also. So I get 10/15. Now, 74 and 3/15, subtract 61 and 10/15. Problem here is I got to take the 3/15 and subtract 10/15, which if I do that, that's going to give me a negative fraction. Not so certain I want to do that. So what I can do is what we did with number 9. I can borrow a whole from this one, call that 73, and I'm going to bust that whole up into how many equal pieces? Yeah, I'm going to put it over here and add it to this piece here. And I'm going to call it 15/15. Tell me again why I'm calling it 15/15. Yeah, because our denominator is 15. Okay, so 3/15 plus that whole that I busted up gives me 18/15. What is 18/15? Now subtract 10/15. I get 8/15. I got to take the 73 and subtract the 61. So 3 subtract 1 is 2, and the 7 subtract the 6 is 1, and there's our final answer. Okay, that one looks scary, but that's not that hard, is it? If it is, I promise we'll practice it some more. All right, moving on. Okay, before we do this one, I want to make an estimate. And actually, I think what I'm going to do is I'm going to make a range of estimates that I think this answer is. Okay, and I'm going to do it this way. I'm going to round both of these and then multiply and see what I get. 1 and 1/3 rounds which way? Yeah, it rounds down to 1. And 2 and 3/4 rounds to what? Yeah, that rounds to 3. So I would say on the high end, well, maybe 3. Let's put 3 here in its own separate little cloud. If I rounded this up to 2, I know definitely on the high end the answer's 6. Okay, I definitely know my answer is not 6 because I rounded both of those up. 6 is too high. All right, I'm thinking it's more like 3 maybe. If I round both of these down, I have 1 times 2, which is 2, and I know that's too low. So put that in there. I'm really thinking my answer should be somewhere around 3. All right, so let's do the math. All right, multiplying fractions is no problem. Tops times tops and bottoms times bottoms. And I hope you all know why that works. But if you've got mixed numbers, you've got to change them to improper first. Okay? 1 is 3/3 plus another 1/3 gives you 4/3. 1 and 1/3 is the same as 4/3. The trick is, or the shortcut is to take 3 times 1 and then add this 1 to it. Okay? 2 and 3/4. Well, 2 is the same as how many fourths? Yeah, 2 is the same as 8/4. Plus another 3/4 gives you 11/4. What's the shortcut in getting that? Yeah, take the 4 times the 2 and add 3 to it. All right, now we can take our tops times tops and bottoms times bottoms. 4 times 11 over 3 times 4. And I know a bunch of you are going to go ahead and do this and then reduce. But what I do is I see that there's a 4 in the numerator and there's a 4 in the denominator, and I know those will cancel each other out, giving me 11/3. Up here, you guys are going to divide by 4, and get the same thing. And then we have to change this back to a mixed number. 11 divided by 3. 11 divided by 3. 3 goes into 11 3 times. That's 9. When you subtract, you get 2. So our answer is 3 wholes and another 2/3 of another whole. right. Woo! Let's see if we can get in 12 before the time runs out. We've got division. 12 is always division with mixed numbers. Okay, let's make a little, oh, by the way, what was our estimate back here? Didn't I say our estimate was 3? I think my answer is reasonable. All right, forgot to check that. Let's do another little estimate here. If I call this, well, 4.5, let's call it 4 divided by 1. I get 4. What if I round that? I wouldn't round that up, but what if you called this 4 and divided it by 2, rounded it up? You get 2. What if I rounded this up to 5 and divided by 1? I'm rounding that down. I get 5. What if I call this 5, divided by it, round that up and call it 2? I get 2.5. All right? So my high and my high is 5 and my low is 2. I'm going to predict my answer somewhere at about 4, roughly about 4. Okay? And this is what I see a lot of kids not doing and coming up with really crazy answers. All right, dividing fractions is easy as pie. Flip the second one and multiply, but you have to change these improper first. So 4 times 2 plus 1, 9 halves, divided by 8 times 1 plus 3, so that's 8, 9, 10, 11 eighths. Dividing fractions is easy as pie. Flip the second one and multiply. All right. How do you multiply fractions? Tops times tops. Bottoms times bottoms. All right. Now I'm sure what you guys are doing is just multiplying straight across. What I'm looking here, myself, I'm looking to see if there's anything that will cross cancel. Once you've got one fraction, you can look for cross canceling, and it'll happen right here. 2 goes into itself once, 2 goes into 8 4 times. Now when I multiply, I get 36 over 11. So this says 36 divided by 11. 36 goes in the house, 11 goes out here. 11 goes into 36 3 times. Subtract. All right, so leave your answer like that. Your answer is 3 wholes and another 3/11ths of another whole. Does that match our prediction or our estimate? Yeah, it's pretty close. I knew it was, I knew it was going to be somewhere in there between 2 and 5. So I like my answer. I think it's good. Okay, we're almost done here. The last section on the computation test is always your operations with integers, adding, subtracting, multiplying, and dividing your integers. Okay, so on this problem right here, we've got 20. We are subtracting 38. 20, if you start at 20 and you remove 38, don't you wind up in the negatives? Yeah. So I hope you guys learned last year that subtracting is the same as adding the opposite. If you haven't, I'm sure that we can find some time and work with you guys on that. So anytime you see subtraction, you could add a line, change the sign. So what's 20 plus negative 38? Yeah, you get negative 18. I just said that subtracting is the same as adding the opposite. This right here is not subtraction, that's a negative sign. This right here is not subtraction, that's a negative sign. Here's your subtraction. Subtracting is the same as adding the opposite. The opposite of this negative is a positive. So what we've got here is 8 plus 17, which gives us what for an answer? Yeah, positive 9. Okay? Right here, what's negative 8 plus another negative 6? Yeah, we've got negative 14. Here I've got 8 and I'm adding negative 6 to it. What do we get? 2. All right. Here, negative 48 This fraction bar is a division symbol. Negative 48 divided by 6. What's a negative divided by a positive? I know you guys learned this last year. Negative divided by positive is negative. So our answer here is what? Yep. All right. Here we're multiplying three negative numbers together. Okay, so we're going to start with the first two numbers. We've got all multiplication and orders of operations says multiply in order, multiply or divide, whichever comes first in order from left to right. So we're going to take negative 2 and multiply by negative 3. Negative 2 times negative 3 is positive 6. And then go ahead and multiply that by the next number in line, the negative 4. Positive 6 times negative 4 gives you what for an answer? Positive times negative, negative, and your answer is 24. All right? Here, I hate the way they do the fraction or the fraction bar. It's really a division symbol slanted like this. I don't like that, but that's what it means. It means the same thing as this. 24 divided by negative 8. A negative divided by negative is what? Positive. 24 divided by 8, 3. Here I've got 7 times negative 6, positive times negative, negative 42. Okay? And I know some of you guys are probably going to need some more work on this. And, you know, if you want some extra help working on this, let me know and I'll certainly do that. All right, guys, we're done.